Hey, good morning, everyone. So now it's about the Newton divided difference for the interpolation. So as the name show you, it's created by Newton and it include the difference, and then we need to divide the differences. So that means that we have a two difference so that we can divide both of them. So basically it can be as simple as that we find the difference and then we divide the difference and then we substitute all of them in the given formula. So these are the formula will be given. Okay, so first of all, let us focus about the first formula. So this formula is show you that the fi prescript the bracket 0 equal to the fi. So that means if you equivalent to the given fi, okay, for our first fi prescript bracket 0. So after this, we have a prescript bracket 1 and bracket j. Okay, now it's j already. Okay, so the j will start from 1 and then 2 and so on and so forth. Okay, it depends to the given data and also the order that we want to estimate. And this is a difference. So you can see that. So for the numerator, so there's a difference for the f, and then it divide by the difference of the x. Okay, so and then you can see there's a j plus 1 here. This means the next I plus 1, it's not j, I plus 1. So that means it's a f, I plus 1, the next f minus the fi. Okay, and then divide by the si plus j minus the si. Okay, so these two formula be given. So after that, we're going to using these two formula to come out the table. Okay, later I will show you the table. After we complete the table, we're going to substitute those value into the formula so that we will get this Pn. So as you learned in the previous section, the n equivalent to the order, whether there's first order, second order, third order, or the quadratic, okay, the fourth order of our interpolation polynomial. And then this, you can see that this f naught, and here also the f naught, and here also the f naught, and here also the f naught. So what's the difference is the f naught prescript to different value. So this one prescript to a bracket of 0, this one bracket 1, this one bracket 2. And besides, on top of that is the production. Okay, so this is a s minus s naught. This one s minus s naught, and then multiply to another s minus s1 in this time, and so on and so forth. Okay, so all of these three formula be given to you, so you need to learn how to use the formula. Okay, next, this is what we have go through just now, and this also we go through just now, and then okay, so this example that we're going to use. So this equation that we have complete using the Lineage interpolation. Now we're going to solve the same equation using the Newton divided difference. So again, we're going to estimate the year of 2007. So first of all, we're going to tabulate the I, okay, as usual, the I. And next is our X, okay. X in this time is a year, the independent variable. Start with 2020 until the end, okay. So want to highlight that because we want to estimate the 2020 and 2007, so that means we must include this point, correct, these 2 points, okay, to be the interpolation. Okay, since all of the point are required, so we need 4 points, so that means we can using this to estimate the quadratic, okay, or the fourth order polynomial interpolation. And then next is our okay, our fi, okay, fi this is our prescript 0. So as we learn in the formula, okay, formula here, okay, so it's equal to the given fi. So that means we can just copy the given data, say it's given, okay, it's a carbon dioxide. So we're going to copy it here, 4.1, 4.4, and so on and so forth. So far for these 3 column are the given information. And next, we're going to do our F1. Okay, Fi prescript 1, Fi prescript 2, and so on until the final one. Okay, so this is what we're going to do. And then we're going to expect something like here. Okay, so this will don't have anything. Here also don't have anything. Okay, so what we're going to come out is something as you see in this slide. Okay, we're going to fill in the blank here. Okay, those are already covered using this. That means that will be don't have value here. Okay, this is what we're going to expect. Okay, so first step, build a suitable table for this case. Okay, so this is the table that we need to fill in. Okay, so next, okay, so let me make it smaller. Okay, so how are we going to fill the 1, 2, 3, 4? Okay, our Fi prescript 1. So as a formula given, okay, so this formula, so we're going to get the difference, am I correct? The Fi plus 1. So if the I is 0, so here we're going to using F1 minus a F0. Okay, so this the numerator, and then if we're going to divide it by the denominator, that will be the Si plus j. So for this case, the j is 1. So that means it will be I plus 1 minus the Si. Okay, so this for the j when j equal to 1 for this column. Can make it smaller. So here we go. So this framework. Okay, they already framed them. Okay, so that means we're going to get the difference for this, the Fi. So if here we be get a 0.3 minus minus, no minus, okay, because it's 4.4 minus the 4.1. Okay, so that now is 0.3 for this, and then divide by difference of here, so it will be the 2. Okay, so 0 by 3 divided by 2, so you get 1.5. Am I correct? 0.15, no 1.5, 0.15. Okay, so this is what we get. So after you settle this one, you can continue for the next one. Okay, so this is the thing, the value that we need to focus. So again, so the difference between these two, so it's a 0.2 because it's 4.6 minus the 4.4 is 0.2, and then divide by here. Here is the difference 1. Okay, so you get 0.2. Here we go here, 0.2. And then you repeat the same process for the rest. Okay, this and this, and that's all. We cannot continue already. Okay, we cannot continue here. So that is why here we cannot fit anything. So the Fi to power bracket 1, it will be less 1 number here. Okay, so this is the thing that we get. So this is the step 2. Okay, it's not step 1 anymore. Step 2. Okay, solve F1. Okay, so after solve this one, of course next should be we solve the second one. Okay, so here we go. This is the second one. Okay, so stop, settle. Next, step 2, step 3. Okay, step 3, we try to find this again. If we base on the formula, okay, formula is here. Okay, so you can see that this time our j is 2. I'm correct. J is 2, so here we're going to using the j equal to 2, 2 minus 1 equal to 1. So that means we're going to using the f prescript 1. Am I correct? So that means this one. Okay, so that means we are not going to use this one. So that's why we can hide this already. Hide this colon. So that means we're going to using this. And for the s, you can see that now the j is 2. So it will be I plus 2 this time. Okay, I plus 2. It's no longer I plus 1. I plus 2. So that's why the frame, okay, the frame, okay, I call this as a frame, okay, that as I highlighted here. Okay, so you can see that we're going to different these two. Okay, 0 0.2 minus 0 0.15, you get the 0 0.05. Divide by the difference of these two. Okay, as I mentioned, when the I equal to 0 and z is 2, so 0 plus 2, we jump to here. Okay, so this one we don't want to see. I think maybe I make this one bigger, is clearer. Right, okay, like this. So that you might hopefully feel clearer. Okay, like this. So I, and then this one I plus j is 2. Okay, and then the difference between this will be the 3. So 0 0.05 divided by 3, this here you go, you get the 0 0.0167. Okay, and then you repeat the same thing. Okay, for the next, okay, you get minus 0 0.05, and then you continue again, you get the final f I prescript 2. Okay, you get this one, and that's all. So we solve the f prescript 2. Okay, so next, okay, let us continue. Next, we let say this step 4. We solve the f prescript 3 this time. So again, according to the formula, here you go, there is the thing that will be used. Since the formula is the same, hopefully you can remember. So now the I plus j is 3, so 0 plus 3 you get here. Okay, that's mean for the x we only consider these two value. Okay, and then for the f, again, since it will be the what, it will be the, when we trying to estimate the j3, so we're going to using the f j minus 1. So that means it's this one, the j will be the 2 when here j is 3. So you're going to using this 2 point. Okay, so again you get the difference of the f as that frame at here, and then divide by here, you're going to get minus 0 0.0167. Okay, let me repeat. So you get the difference first, minus 0 0.05, okay, minus this one, 0 0.0167, divide by 4. Okay, why 4? Because here 2006 minus 2002, you get 4. And then eventually you get this minus 0 0.0167. Okay, I hope you get the answer. That you repeat the same formula to the next, that you can get the 0 0.0083. Okay, so after that we complete the step 4, and then repeat again the step, go to our final column. Okay, step 5, final column. Okay, we go to estimate this one. So the same thing, so you can see that now we only what you call we only do once okay, for the final one, because as you can see that it's I plus j is 4 now, so 0 plus 4, that's all. Okay, what I mean that's all, because you cannot further to the next step, correct? There's not any data already. So that's why we only estimate once only for our final value. Okay, the formula is the same. Difference divide by this difference, then you get the 0.00442. Okay, that you have done all of the step to complete the table. That our final step. Okay, so for the final step, okay, let me that this thing first. Let me cover it. No, okay, cover this one first. Since we already used the first two formula to complete the table, so now we're going to use our final formula, this one, the fs approximate to the f, and now in this case the n is 4, okay, n is 4, that means it's a quadratic, okay, polynomial interpolation, and then the first term, what's the first term? The f naught, and then at which column? The script 0 as me is this one, correct? So you're going to take this one 4.1 as this one, okay, this is a 4.1 okay, take note so 4.1 okay, let me adjust a bit, okay, nice, 4.1, okay, 4.1 okay, 4.1, and then next you plus, or make it plus, and now also the f naught, but now prescript is 1, so that means is here 0.15, okay, 0.15 bracket x, okay, this time we want to estimate our x is 2007, so it's 2007 minus what, minus the s naught, where's the s naught? S naught in this one 2002, okay, so that's why you see this one 2002, okay. So after we done this one, we have it done now, we need to complete again. Okay, we need to proceed to the f naught to power bracket 2, let's make this one, okay, power next, so we plus again, okay, this means hide those we are no longer use, so now we are here, the f naught to power bracket 2, 0.0167, so that you can see I written here, so same thing, s minus s naught, s minus 1, so this is s naught, this is s1, 2004, okay. After done this one, repeat again, now repeat, continue again, okay, you can see the bracket is getting more, okay, just not only 1, now already 2, now have a 3, and you can expect the next will be we have 4 bracket for this s minus s naught, s minus s1, so the final one will be until s minus m plus 1, m minus 1, so it's, and the s4, this one is what, this one not m plus 1 minus 1, so it's 3, okay, so this answer, and then after that you need to using your calculator, okay, I think it's quite long until 2006 only 2008 we are not included okay, because it's m minus 1, okay, so n is 4, 4 minus 1 is what, is 3 okay, and then you, after using your calculator, you should get it, the answer 4.7255, okay. So this is the demonstration for our example, how we approximate using the Newton divided difference, okay. Okay, next is about same question as well, but we can use a so-called normalization. So normalization, that means we're going to normalize the independent variable only if necessary. So it's optional, it doesn't mean you must do it. Okay, for example, the same question, if we're using the baseline as a 2020, so that means everything here we're going to minus 2020. And to do this, it will be a good idea we add a colon here, the new colon, we name it as a TI. So 2000 2 minus 2002, you get 0. 2004, you minus 2002, you get 2, and so on and so forth. So that's why we come out with the new independent variable. So what's the benefit? Once we come out this one, you can see that the formula or the value that we key in or we return will be much simple. 5 minus what? 5 minus 0. What's the previously? Previously will be the will be something longer. Okay, it should be 2000 something. And then here just now we trying to estimate the 2007, correct? We need to normalize as well. So that's why we need to minus 2002. So that's why we get 5. So this one is how the 5 get from. And this 0 previously it will be 2002 and now become 0. Okay, and then 2 and here previously will be 2004. So you can see the benefit is simplify it reduce significantly the value. Eventually we're going to get the same answer as well. So again, the normalization only can be applied to the independent variable. That's mean our x. Okay, don't apply it to our dependent variable, the fi. Okay, only apply to here only if necessary. Okay, so this is the thing that I would like to share with you. Okay, next is about second order. As I mentioned just now, since the previous example it don't mention that we need to use which order, so that's why we use all of the 1 2 3 4 5 6. So that's why it will be the p4. Okay, p subscript 4. So for the second order it will be the p subscript 2. Okay, p and subscript 2. So how are we going to do this one? So again, we want to estimate the 2007. So as you learned previously, 2007 at where we need to searching is at here. Am I correct? It's between 2006 and 2008. So for interpolation, these 2 points must be included. So and next is a second order. Second order, we need how many points? Okay, you can pause and think first before continue. So the answer will be 3 points. Okay, we need 3 points. So that means we're going to need these 3 points. So here we go. We're going to tabulate the data. Okay, as usual. So we need 3. It will be the I not 1 and 2, and after that we fill in the 2005, 2006, and 2008, and next will be our dependent variable that we want to predict. The one will be the capital outside, so you can fill in the next column. So after done this one, what is going to happen? We're going to here we already have a f naught. I'm correct. Next should be we want to estimate the fi. Okay, fi. So this is our fi. So how are we going to estimate this one? Okay, hopefully you still remember the frame. Okay, the frame will be the 4.7 minus the 4.6 and then divide by the difference of this one. So that's why you get the 0.1. Okay, we're going to get 0.1. And then same thing for the 0.05 here. Actually, it's a different here. Here the different 4.8 minus the 4.7, you get 0.1 divided by here it will be the 2, so you get a 0.05. So after you get the f prescript bracket 1, so you're going to do the last one. I'm correct. Last one is this one. Okay, how to get this one? First is different about this one. 0.05 minus 0.1. Okay, 0.05 minus 0.1, and then you divide the difference of the 2008 and 2005. So the one will be the 3, and then this here we go, you get the minus 0.0167. Okay, so this answer. So after you get this one, okay, that you can using the third formula. Okay, the third formula. Okay, the third formula here to get the estimation. So f naught is here. Okay, f naught is this one, 4.6. Okay, 4.6, and then the f naught to power 1 will be 0.1, and then you multiply to this, and lastly until here only, because it's a second order. So that's why you see the x that we multiply, the order that we get also second order. So this could be the where the name come from. So here remember to write your Pn equal to 2. Okay, and then I'm going to share with you the answer. Okay, so this answer, okay, I want you to want you to write it, want you to practice, okay, practice by yourself. Okay, you should get these two. So which one more accurate? Okay, to answer this question, which one more accurate? We need to know the exact solution. So that's mean we cannot answer. We cannot give you an answer here. Okay, so there's no answer here since we don't have an exact solution here. So if you have exact solution, you can calculate which one is closer, is nearer to the exact solution. Okay, so this is the answer. But we can see that yeah, normally more order that we use, it should be more accurate. Normally, the one is normally, but it's no guarantee. Okay, it could be overfit as well.